Hello, welcome to today's episode of Frivolous Gravitas, where we will be very frivolously going into how we approach learning and how we gain knowledge and form that into wisdom, but not just knowledge, but also information in itself and how we turn that into knowledge. So Kris is going to be guiding us through this as we look at how we go about gaining the skills that we have. Whereas, a lot of us feel that we can just memorize something and then we'll know it. But memorization is just the regurgitation. You download something and you can regurgitate the data, but then data is pretty useless on its own. Anyone who's gone to a spreadsheet that they didn't make, see all the numbers and words and stuff, and it doesn't really mean anything without context. So when we want to actually know something, we have to abstract a bit. We have to look at what we're doing. And to look at this, Kris is going to guide us through the subject of coding and how, though not the thing in itself, it is a good example of how we can do better at learning, rather be more efficient at learning. I hope I got that. Through pretty clearly.
If not, it'll become clear as we go along, I'm sure. Yeah. Sorry. To begin with, I guess what I wanted to get into today was abstraction and conceptualization, mostly because my inherent penchant is for philosophizing routinely and as a matter of religion for all intents and purposes. Practically speaking, that's how I apply my education. And the reason why philosophy has always been so near and dear to my heart is because I early on in my life learned the benefits of learning how concepts and structures work as integrated systems of complexities, as opposed to studying for the mere sake of achieving a grade or for the end goal of getting a job or to appease somebody or something simple like that. And I find even to this day, amongst not just friends and family, but people I've worked with and a lot of YouTubers and other podcasters and developers out there, often they don't realize themselves having the same ideological constructs of education and learning that they would probably tell you outright and explicitly they don't subscribe to. So as an example of this, when we talk about constructs or systems or organizations and things like that, a lot of people, and I'm not just saying this as hyperbole, I mean, you can see it as like in journalists and politicians and everywhere you look, even on TV and in news, and people will tell you, if you ask them outright, if there is any value to abstractions. So simple ones like math. Arithmetic is an abstraction. There is no actual number one. It's just a number that describes a quantity of some things. And other animals can tell greater than or less than, but they can't necessarily tell the same, the concept of the number one. They can't ascribe that to a symbol like a number, the way we
can. So, but like the number one exists as a property of something. So but the number, there isn't a platonic number one, except for the fact that everything that can be counted as one is one.
Right. Okay, but there is no one.
Getting
one
stupid
thing.
Complex, but essentially it's a property of something to have a number to it or an amount. So there is one mug, and part of this one mug, of what makes it one mug, is the fact that it is one. And so because we can't have this concept in reality, it is a structure in our minds that relates to reality. We have this abstraction, but that doesn't mean the abstractions aren't real.
Right.
So
And that's sort of what we wanted to drill into today, is the reality of those abstractions, because it seems to me like a lot of people are cutting themselves off at the knees. Once they get to a certain level of abstraction, they sort of feel like they don't need to learn any more abstractions for the rest of their lives. Like school was all there was. Now that I can count and multiply, I don't need abstract concepts anymore. And I think that's patently false in real terms. And today hopefully I could outline how in real terms, continuously picking up more abstractions as we go along our daily lives not only benefits us individually in like quality of life wise, but it also makes it easier and less difficult to do hard things, because abstractions are as a function of themselves purposeful in the sense that they can be applied to a wide variety of different applications, whereas learning one specific thing or a factoid or something only applies to that one context in which it was derived. So to put that in other terms, I might consider like education being an obvious one. And since we already started with math, there's no perfect circle, but you can do math related to perfect circles because of the abstraction. And the utility of using circles may not be evident or apparent to most people in their daily walks of life. But when you think of all of the things that you use on a daily basis and on an hourly basis, whether that's the telemetry of the cell phone signals, or it's the rotation and RPM of your engine, or any number of things from nutrition and health and wellness to how to raise a child. All of these things are premised and based on fundamental core values, which they themselves are abstractions of what we hold dear in life. So a big part of why this sort of bothers me is not that people are doing things wrong or that I think they should be doing them differently. It's that I'm seeing a potential gain or benefit that people are ignoring for no reason other than the fact that it seems too complicated or seems too difficult or it seems useless, because the abstraction itself isn't it's not a glowing emblem of something productive, or it doesn't make their paychecks bigger in the immediate sense.
Yeah, so you have this thing which, if I learned it, it would be of little utility beyond the fact that I can know it. But I think we need to bring it back down to earth a bit, a little maybe less abstract, I guess. But now the world is pretty complex. So you think if I specialize, I'll be better suited to succeed in the world. Now, if you get really good at one thing, then chances are you don't have to generalize. So you get a job as a clerk, and you learn how to clerk really well. You really got that down. The mental sets that you have to work through your day are, in your muscle memory. You don't need to learn anything beyond that. And you've got this. And that's a comfortable little niche. And there's nothing wrong with that. But to push beyond that. So what do you do when you get home? What do you do with the rest of your time? Or are you just a clerk? When it comes down to university students, I think we see this a lot, is that you get people siloed in their own professions, who like, I'm a historian, I don't need to learn science, or I'm in the chemistry department, or I'm in the agriculture department, I don't need to do this and that. But always the people that were the most interesting, at least, I'm not saying be interesting, take different sorts of classes, although that happens as a byproduct, are those, the engineers that would come to a religion class and think, okay, this does have relevance because I'm looking at what I want to do from a different perspective. And then the other side of that is this entire conversation, sorry, I think is what you're trying to get at is with something like what we talked about last week. With history, you learn the dates, you learn the names, but the William the Conqueror in 1066 don't really mean anything without context. And then what are you going to do with that? Well, you know this thing, so you can pass the test. But unfortunately, life isn't a test. Life after the test is what's more important. So you need to be ready to not just know these things, but act upon them in a way such that you I think what you guys, I guess you were trying to say is that we're preparing for a test when we should be preparing to be versatile in our jobs. So you're gonna pass the test. You're gonna get your nursing degree or your doctorate or whatever. You're gonna go into the workforce, and they're gonna say, "Okay, here's your project. Go." And you're gonna be like, "Oh no, this wasn't the test. What do I need to do? What do I need to do? I need to know the answer." And the problem is that there is no the answer. The answer is something that you have to be creative about. You have to learn to be creative about engineering. You have to learn to be creative about chemistry. I need to be learn to be creative because the answer, if we knew it, yes, it could be, okay, I need to boil this to a certain point, collect the vapor, distill, do all this stuff, which I can learn from discrete skills that I've memorized and honed. But then beyond that, you need to be a problem solver. What happens when the equipment fails? What happens when your boss says, "Can we do this faster?" What happens when you get put on a team to design a new chemical with very little input, and you have to think outside the box? So,
yeah, that's definitely part of what I wanted to get at. But I also wanted to sort of, in addition to that, there are aspects of life that aren't so clearly defined. It's not so obvious when we're not talking about a job, when we're talking about raising a kid, or how to educate people, or how to govern ourselves politically, or how to manage our money and our investments, or how to make a trade for a sports team. It's being able to know where the limits or the boundaries of your knowledge are. That's also a creative process, being able to think up things that you haven't thought of yet. And I think a big part of abstractions and why I think people don't appreciate them wholly is because they look at them as, like you were saying, that means to the end, where they're looking for the end goal or the right answer or that true result. But learning and memorizing a bunch of recipes could make you a good cook in the eyes of the people who eat all your food and love it. But it does nothing to help you figure out why something didn't work when it doesn't work out. Did you have the heat on too high? Was the dish too shallow, too wide? Was the sauce too watery? You know what I mean? So, like, there are spillover effects of understanding fully something from the ground up versus just having memorized it or known it because you were taught it specifically and explicitly to do it in this one direct kind of way. So finding that comfortable niche in what you want to do for a living is about quality of life, because it's not just what you take home at the end of the day, bringing home the bacon. It's your ability to manage a crisis, or to manage your own mental health or nutrition or fitness. It's your ability to relate to a person who's not you and who has a completely different way of thinking and believing and functioning.
Right. So instead of saying, "Why has this happened to me? This wasn't in the manual." You know, I was like, "Well, what's the answer? Like, give me the answer. I need to get it right." And I see this a lot with a lot of people that, like, give me the answer. Well, there isn't an answer. You have to work something up, and you have to try something new. You have to, and it generally comes up a lot when you give people questions that are almost like you ask an opinion. What is your thought on this? Or what does this make you feel? They're like, what? My favorite was in one of my French classes, I had this professor who he was, how do I say this? Very,
strict?
No, just weird, but in a really good way.
Oh,
he put I mean, he definitely was very forceful. He's like, you must feel. If you do not get out of my class, you're useless to me. Ah! And he'd put a picture of smoke up on the board, and he'd be like, point to one random person in the class, and it was random. And he would be like, how does this make you feel? And they'd be like, it's smoke. Wrong. How does this make you feel? Like flying in the dark. And he's like, perfect, excellent. And then we're like, how does this make you feel? And the other person in the back goes, nothing, blank. There's no, it's not a value. You need to come up with something that's beyond a value. It's you're swimming in the subjective at that point. And there isn't an answer to every question, which is, I don't know, maybe you were teaching just materialist focused because, I don't want to pontificate on that quite yet. So,
it's not to say that there's no place though for memorization and things it's sort of hand in hand. But what I think the balance is skewed more towards that goal oriented, learn this for this, 1 + 2 = 3 type of thinking. And that's sort of what I wanted to use to bring into the programming dynamic of our conversation today, because I think it perfectly illustrates how you take binary logic operators and you make dynamic systems out of them. And to get into that, I think the easiest way is just to think of a simple function. So a simple function could be thought of like an algorithm. Like if you wanted to write a function that adds two things together, you would need a name for that function so that you can call it. Let's call it sum. And then you need to pass it some parameters so it knows what to operate on. And we can call those A and B. So if the name of the function sum is defined by adding A with B and outputting that result, you could then say the variable name result equals sum 1 and 2. And then it would add 1 to 2. Now, that sounds like a really simple and rudimentary program to run. And obviously, most computers don't need to have that written into them, because obviously, if you had a sum function adding 1 and 2, or item 1 and item 2, that would have to be pre-programmed into the language already. So you're not really making an effective program by writing a sum function like that. But what's interesting about it is that you can encapsulate functions inside of other functions. So as soon as you want to do another function like multiply, well, it's along the same formula as the one before. You need a name, so let's call it multiply. You need two parameters, one thing to multiply to the other thing. Well, how are you going to tell a computer to do that? Well, you could use your sum function, or you could use an add function instead. So like 2 times 3 = 6, because 2 + 2 + 2, doing that add function 3 times is 6. So you can write a function that embeds another function inside of it. And then suddenly you've got a multiplication operation. And within a multiplication operation, you can apply that to Euclidean geometry, and you can start rotating objects. Well, now you need points and coordinate systems. Well, you can learn them by memorizing points and coordinate systems, and you could know the formula and everything off the top of your head, but without actually being able to conceptualize what you're doing on a two-dimensional space, it's not at all clear or obvious that multiplying 2 points is a rotation. Do you know what I mean? But once somebody understands how matrix multiplications work without memorizing them, suddenly they can start applying them to things like machine learning, three-dimensional graphics engines, video games, and you can go on and on and on about like neurolinguistics programming and CAD software. So being able to build all these tiny structures and then building larger structures that encapsulate those structures is very similar to how like computers were built. We didn't just build a computer that was 3.6 gigahertz and 18 cores and we didn't start with that. We started with tiny, tiny little circuits, and then we bundled a bunch of those complex logic circuits into a chip. Then we bundled a whole bunch of chips onto a board. And then once we took that board, we could then make computer making machines that actually etch onto boards with extreme precision and accuracy, using those chips to build higher density chips with more computing power on them.
Yeah, a lot of that was done with the what if we tried this mentality, or we need something like this. Let's just build it. I keep thinking back to the mother of all demos where they put together a ton of different concepts, hypertext, CRTs. You have display of text. You have you call these mice and human interface controls, so that you didn't have to like type into a keyboard, and then the computer would have to read the punch cards transcribed from the keyboard, and then so you could just type in like your code, and it would read the screen as if it was reading the thing. And so they put a bunch of these together, and in 1969 they got what we have as like the first form of what we have in our computers today. But like even something as simple as a transistor was, it took more than just memorization to figure it out. They needed to know, okay, we have conductors and now we need semiconductors. And so we need to be able to make it so that if we put in a charge and we hook another charge up to it, then one thing happens, and if we don't put that second charge on, another thing happens. So we have a 1 and a 0. We had vacuum tubes, but those were huge and they created a lot of heat, and they were expensive to make. But a transistor is tiny; it burns out, and who cares? It's just some
But to
silicon.
create the vacuum tubes, they had mechanical systems of switches that were actually push buttons on springs on and off with latches, right?
I think a lot of the
Turing
vacuum
machine was essentially just a mechanical structure that went through with an algorithm and processed through cha-chink, cha-chink.
Yeah, the machine was the algorithm.
Yeah.
So before anything digital, a computer was just it was designed to do the thing it was built to do and nothing more. Until you get programmable computers in the 40s and 50s, but those were even still very specialized. And what Ted Nelson, another eccentric, would have called the all-purpose machine, which we don't have computers, we have all-purpose machines. And they are, I think this is probably what you're getting at, is that these machines, they don't just compute. That's part of what they do, but what they do is whatever we can imagine them to do. And the only thing limiting us is storage, but then the only thing limiting storage is price and physics. But at the same time, within the parameters of the machine we have, like that even I have right in front of me here, I have a lot of options where I just to apply myself to something. Now, the only thing holding me back then is my imagination. So if I want to create something new, what I have to do is first I have to figure out what I want to create. Well, I could look to my ascribed list of things I could do and just apply those. And you're just like, oh, I'm going to put Windows on my computer. Okay, good. And then what are you going to do with that? But if I want to do something new, then I have to use a different thought process. I can't just go to the list and see the programs I can install, the uses I can have for this computer. The uses I can have for this computer are limited by my imagination and then by the time it takes to implement that. Now, the time gets quicker when I learn to think better, when I learn to think beyond what is in front of me.
And sort of what I wanted to get at with that, sorry, just to stop.
No, yeah, I'm trying to back you up here.
Okay, it's an iterative process. It's not just that you have something in mind that you want to create and use your computer to do. There are things your computer can do that you can't even imagine yet because you haven't had time to even look into it.
Right. Wouldn't it be cool if my computer could,
in the world,
if I could hook up my computer to my light switch there, and then I could do it. I can probably think of in a couple minutes on how I could do it. But then I think it'd be neat and I'd learn how to do it, but I could just walk up and go turn it off and on. Now,
But more
That
practically speaking, you can start a podcast channel with the computing power sitting in front of you. And years ago, we never had a podcast channel. Why is that?
No.
It's not because we never had anything to say or anything to record. It's just, it takes time and energy and effort to learn the tools. But the tools themselves are abstractions built on layers of abstraction, built on layers of abstraction, built on layers of abstraction.
Right. Your computer isn't just a computer. It's a bunch of different shit. It's this gestalt of concepts put together that works.
and you can't just jump steps, right?
No.
We couldn't just invent one transistor and then suddenly, oh, well, why don't we just build a CNC machine and an EUV process that makes 7 nanometer nodes to the, by 12 billion so that we can have microcomputing and cloud computing. And we couldn't even fathom the internet until after a network was first established. And you couldn't fathom a network being established until after we had electronic communications.
Yeah, well, that reminds me of people do that in history. They see history as just this construct that's happening, and you just got to learn what happened. And it's like, oh, it's very literal approach to it. But then you see people like, oh, Abraham Lincoln was actually terrible because he could have actually done more for why didn't he know to do this with this, or why didn't he know about trans people or something? He was actually a terrible person. And it's just like, he was working with the abstractions that he had. He was working under the constraints he had, and things happened the way they happen. So you can't just, the problem there isn't with Abraham Lincoln. The problem is with your interpretation of this is what should have happened. This is what can happen. This is what I want to do. This is what I can do.
That false projection of what they would have done had they been in the past in the same shoes. And that's exactly what we wanted to get at here today with appreciating the value of abstractions, even though we can't see the future, to know that the future is created by our ability to conceptualize and grasp complex ideas and encapsulate them into things that we can grasp and manipulate.
The problem I would see with something like the Abraham Lincoln story, or why didn't they use this for this, is not a lack of the imagination of, say, someone like Douglas Engelbart or something, or the transistor pioneers, or Bill Gates and Steve Jobs and Wozniak. It's a inability to form a opinion of oneself, because if you're saying something like that, you're generally saying something that's not your own words, or not your own words, but it's something that's you're following an algorithm that you didn't create. And you, in your life, well, all these things, these abstractions of speech and knowledge that we use to navigate all these ideas are, we navigate them through these algorithms. And, you learn them at school. Okay, if you read this, then I need to interpret it like this. And then I need to, make sure that I'm not being biased or this or that or that. But you don't really do that. You just, you integrate those ideas into your analysis and just go with it. And then when you read something, you use those algorithms that you've learned. Now, the thing isn't that when you're reading something, so you pull up a book and you say, okay, I'm going to read it. Now the teacher told me to read things and watch for this. Okay, now I've got this list of things I need to pay attention to. Now, what you want to do is you want to write your own algorithm. You start with these algorithms that the teacher gives you. You check the sources, look at the structure, what's their argument versus what's their thing, what are their sources, what's their data say. And then you use that, and eventually what you want to do isn't to be able to just know what all the, sources are. Okay, I've read all the, canon texts of my faculty or of my field, and therefore I already know it. Wrong. No, it's not the books that you want to have read. It's the skills to read the books that you want. You want to write that yourself, because if you don't write it yourself, you start doing stuff like Abraham Lincoln was racist, and you start doing stuff like, well, This is actually a derivative. You start saying things that are not your words. You're using the algorithm that your professor or their professor learned, or someone else in the class learned. You've got this implanted abstraction, whereas you can build your own. And this goes for coding, but you're also coding the way you interact with the world yourself. So you can interpret something, this random book I picked up, according to how you think about it and have your own interpretation. And I would say that an interpretation isn't useful or worth any value unless it's a interpretation like that of an individual, because we can all figure out what a government or an institution or a party or a type of person would say about something. So how would this person say that? And it's useful to do that, but I don't need someone from the CCP to tell me what they think about history, because I can get it on my own. I can install that algorithm for a second and be like, okay, that, and install it, and then go back to using my own.
So I would say people, even the ones that need it, that think they need it, they don't. That's what I'm getting at.
Yes.
Those now, people have a false sense of security in the things that are known to all people, thinking that is the way to know things. And I would suggest that that's one way of knowing things for practical purposes. Like if your car is making a noise, I want the mechanic who knows all possible noises and can discern what they might be, rather than the one who's memorized every noise for every car problem.
Right. The guy who...
A new noise will mean nothing to that mechanic. They won't be able to help you.
Yeah, because he instead of knowing, it's reasonable rather than rule-based, which is kind of what me and my wife have been throwing around here, is that, you get people who are like, oh, what's the contingency for this? Or what's the contingency for that? Well, you can be reasonable and look at it for itself, or you could follow the rules and say, we need to go to the book. And the mechanic like that is worth more than he's charging. And he's probably in high demand because it's just like, I know this guy, I know a guy, and he's busy because, he's a good worker and he knows his stuff generally. But I'm a customer. I have to approach that in a way that, because I don't know how to tell a good mechanic. I from a bad one, I can't tell based on, because I don't know that world very well. So I have to use a different algorithm to attain that. So generally I use my gut sense and go in and talk to them. And if they're helpful, and generally if they don't tell me, oh yeah, we'll take care of it right away, it's just like, if they seem to know and they're actually helpful and they're willing to answer questions, a couple, Luddite questions, not Luddite, laity. Well, questions from the laity of car repair, then generally I can, okay, you know what? This guy, I can trust him a bit to do his job and not be like, oh, hey, you need a new engine, but I got a perfectly good one here. It's only going to cost you way too much. So there's always that fear. But you can go, what you want is a problem solver, because they're solving problems with your engine, and you don't want one that's going to go to the book, because reality isn't all in one book. And I think that's what we're getting at here, is you need to be creative and versatile and almost...
I'm sort of saying there's more value in it, though. I'm not saying that you need to do this or you need to do that, because we should be able to trust other people to do their jobs and whatever. What I'm getting at, though, is what you had mentioned. The mechanic who's memorized sounds is still useful as a mechanic for most situations. But the more valuable knowledge, the more sustainable, life-sustaining knowledge, that mechanic who understands deeply what the combustion chambers and gear ratios and engine displacement mean, that mechanic can then transpose those sets of understandings to other things like fluid dynamics and airplanes. Right. Or they can fix the plumbing in their house, maybe, because they understand one sound is similar to another sound based on the mechanics of fluid systems moving.
Right. So when I was thinking of, the mechanic who knows all those sounds, but when a new sound happens that he's never heard before, he goes, let's move forward, and they can handle that. But at the same time, you have that mechanic who can take those lessons he learned fixing cars or faucets or whatever, and apply that to other forms of other parts of his life. So it's like, okay, what do I need to do here? Well, what I need to do is sit down, look at what the problem is. It's not a gasket. It's my son's not home and it's 11 p.m. and I need to assess the problem. I need to do this. So you're learning. You're not learning a contingency. You're learning to learn as you go.
Yeah,
and
it's processing, and that sort of gets us back to the computer analogy or reference, I guess I should say, because the process of breaking down what you want to build in an application using binary logic and using a syntax and language of a programming construction, that process is applicable to all other aspects of life, whether you're in medicine and nursing or geriatric care, or if you're a politician, or if you're an athlete trying to get the most out of their body for, the pursuit of excellence. There's a whole bunch of offshoots that stem from that type of thought process of compartmentalizing problems, reusing reusable structures, and coding them in such a way that makes them dynamic but very specific so that they're not prone to failure. So in the instance of a mechanic having a noise or something emanating from their faucet that sounds similar to like engine knock or something, they might have an idea of there being a lack of airflow in the plumbing stack. Or a construction worker who understands angles and rotation, they might be more adept at not just inventing things, but also assessing situations. Something completely irrelevant to their field of expertise.
You get someone who looks at blueprints, or they'll be able to be better at visualizing things in space. It's just they get this problem a lot. It's kind of almost a famous problem with soldiers, where they learn all these skills and they come to the civilian world after they retire or get out, and they don't know what to do. They're famously bad at finding a job if they don't have a network to get into, and often they do, but it's hard because I was a soldier. Well, what are you good at? I'm good at section attacks. Okay, what else? Well, I know how to pack a ruck and I can walk real far. Oh, jeez, okay. But one of the things that they're not realizing is that they have lots of experience working as a team. They probably have extensive leadership experience. They probably have, they're probably a lot more immune to hardship than most people.
They follow directions really well.
They're probably, they follow directions, and they can switch tasks on a dime, and they can, they have probably very good spatial and visual skills. So,
and they can suppress their emotional reactions to environmental variables, and
downsides, they probably drink a lot. But so the thing is that you don't know to say this. So, well, I know what I know. And the difference is that you've learned one thing, but the skills you learned, the skills you've honed in learning that and using that knowledge can be applied to anything. You just have to apply it to a different template. So, I can apply, my scholarship to washing dishes. I just have to learn, okay, what do I need to learn? Okay, this, there. Okay, I've got everything visualized. Okay, now I got to stand there and wash the dishes, crank. There's a problem. I got to fix it. So I can apply the things I've learned I just have to apply them to different context. And yes, you're going to have to learn a new thing, but you're always learning new things. So you might as well learn it actively. Have fun.
But it's sort of the difference between learning how to cook a new thing by memorizing the recipe or following the direction, and learning how to cook a new thing because you know how you want it to come out, and you have an experience, a track record of trying all these different varieties of recombinations.
Right.
So to put it in another way, the person reading the blueprints might be really good at something that is completely unrelated to spatial awareness. They might be really good at teaching a child with autism how to read. Like, you have no idea. I'm just saying, like, I'm not saying this is the case for all of these types of people. What I'm saying is, when people apply or learn a skill abstractly, then it becomes more valuable and useful to them personally and to the world as a whole by consequence. So understanding, for instance, math and rate of change, or like calculus. So like finding the area underneath a plotted graph or something like that seems really abstract and arbitrary and probably only useful to physicists and things like that. But when a nurse is in a hospital managing somebody's diabetic care and they can't distinguish the difference between a single meter reading and the vector of change between 2 meter readings, they can give somebody poor healthcare. And it's not because they didn't study, and it's not because they didn't get good grades in school. Their thought process is so fixated on just the grade that they lost the ability to apply what they learn. So the skill they learn isn't actually a skill, it's basically a technique. And you don't want to learn technique. Well, you do want to learn technique because technique helps. But the point of a skill shouldn't be to learn the technique. That's why they're separate.
You see this with children too, because we kind of, when we're young, we push our luck a lot, and we see what we can get away with, and we see what gets us oh, it's so nice, and oh, you're gonna get beat, and generally we're testing reality because we don't know very much. We have generalized inputs and outputs, evolutionarily calibrated actions, but generally we don't know what gets us, more food or more candy, or gets us to watch cartoons when we're like kids. But we learn what works and what doesn't through a process of hair pulling experimentation. Most of the hair pulling is on the part of the parents. It's like, oh no, I screwed up, and the kid runs away. And the parents are like, oh geez, he's trying that thing again. But this process of learning, you don't have to stop it. It's like, okay, you're 8 now, so it's time to memorize facts. Well, the thing is that you can memorize all the boiling points, blah 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 blah, or you can just show them. It's just like, okay, boil the water. When does it start to boil? Or add heat to the water. What happens to it at what degrees? And you're like, well, it started to turn into water vapor at 100 degrees Celsius. It's like, funny that. Why? So this testing and trying and building of our own algorithms is I'm going to keep with that metaphor. And
that's essentially what we're doing with Lego. We're given a set number of blocks and a space that we can attach them together, and there are pretty much an infinite different ways of recombining all these Lego pieces. And that's why adults and kids can play with Lego, because any one of us has never seen every possible combination of Lego.
Right.
We're
or like
constantly
Minecraft.
Inventing new ways for our minds to recombine these puzzle pieces together. Whereas a puzzle with a picture is sort of the same, but it's different. It's the same in the sense that there are like the pieces are laid out in front of you and they're pre-built. So that's like the syntax to the programming language. They're pre-built. But trying to visualize what the outcome will be is very different from building something without any idea of what the outcome will be. Do you know what I mean? Mm-hmm. So like there's a place and there's room for structured play because it does help our brains develop specific traits and skills and applications. It's not to say that they're not valuable. But another thing that is very valuable, if not equally valuable, I would suggest is more valuable, is the abstraction, because it may take them longer to figure out how to do things like compound interest, to figure it out for themselves. but the capacity to figure out compound interest without memorizing the formula is exponentially more valuable.
Right. So it's the difference between you get it and, well, I just apply the formula and it works, which is why I was so bad at math, because I was trying to, like, what is cross multiplication? And everyone's looking at me like, you're an idiot. And it was a bit of a bad way of going about it because I, had other things to do. But I was trying to approach it in a different way, and I was getting the gist of it slowly. But what I was being told to do was just apply the math, and it just works like that. And there's some wisdom to that. Yes, you just keep applying the math, and eventually you'll be like, oh, now I get it. I've been applying it 30,000 times, and now I get it. But sometimes
practice means it's useful and practical. So if it's not something you're going to do every day, then maybe just knowing how to do the useful thing is worthwhile. But
like, and at some point there's like, we have to actually, like, we could just straight up not learn it. We just keep applying it for the rest of our life and never understand it, which is kind of a part of human nature because, well, why do we do this? We don't know, but it keeps the village alive. So we're just going to keep doing it and not ask too many questions because we could break it when it's like a water pump. Where does the water come from? The pipe. So now.
But I mean, with that said, like, not everybody can learn everything, right? So we do have to pick and choose the things we get to know. So compound interest may not be important in your daily life, and it's fine that you can learn how to read a formula and how to use any formula you're given. That's an abstract skill too. Learning how to use any formula and practicing on compound interest formula is very valuable. But what I'm getting at is it may not be obvious and apparent how useful it is for somebody to be able to develop themselves the formula for compound interest. And they may look like they're not learning math very quickly, like me, but eventually they might be writing machine learning algorithms based on the way they learn math. And it's not to say one thing is better or worse than the other, or that everybody should do it. But the unifying structure here is with code, anybody can build anything. They can build a 3D representation of material reality. They can build simulation systems. They can build websites that just display archives. That's all they want to do is data structures and chart graphs and analytics. But with programming, you can also write functions for your business. So if you had a pricing model and you want to know how to produce an estimate for a customer, that's an algorithm. That's something that programming can teach you how to formulate in your head. But without practice, most people just sort of guess and they hope that their intuition and their gut feeling is right. But that's not a useful way of applying an abstraction, to just rely on intuition and then get burned so many times that you finally figure it out. If we taught everybody programming, they would have the tools to use it in whatever application they applied it to down the road, whether that's finance, education, arts. Like music is all sine waves. Being able to manipulate waveforms through math is very much audio production. That's what audio engineering is.
So I don't know how much of I'm very wary of, I guess, talk that says, if we just do this, we'll show an improvement. But because I feel like we actually have to look at the abstractions of it. Because if it works for one person, it doesn't work for everybody. But what it sounds like, and I don't want to reduce everything to art because music isn't just sine waves. It's also the reaction to those sine waves.
But our brains process the math. That's why we find harmonics and things appealing.
But it sounds like what you're describing sounds a lot like concept from that I learned a while ago, where you have this idea that art is greater than reality because you can create anything with art and reality is stuck in one form. So now we have paint and we have a story and we have music, which can create these other states, places, ideas. Now, the technology that we've gained in the last 50, 60 years allows us to do this, but on a more generalized level. So you can only make so many auditory, you only have this much to play with, but with the medium constrains itself with these visual and acoustic mediums. But with coding in itself, you can create anything. It's a tool that is almost more than language, it seems, because with language I can say whatever I want within the constraints of my language when I bump up to complexity. But when you're coding with something, you can create something that either conforms in a different way to reality or creates its own reality within its own parameters.
That assumes that there's a natural fundamental programming language, which there isn't. There are thousands of programming languages because of their applications.
Right. So things. That's what I'm saying is that I'm not referring to one programming language. I'm referring to the concept of
right. That's what I'm trying to jive with your form of art. Just like there are many forms of art, and even though there is a limited band that our ears can perceive of, you can multiplex different waveforms over and across each other.
Right.
The same way that colors can overlap, even though they're just wavelengths of light. You can overlap colors, and shapes can intertwine and meld together. Right. And you can create unique shapes with unique colors, with unique sounds, and make a movie that nobody's ever seen before.
Right. But
art. You can do that with programming too.
Now, I kind of want to bring this back to the practical before we dive out into the abstract again, because with coding, I guess there's that thing, we'll just learn to code, but that's not what we're talking about.
No, I'm talking about the thought process behind coding is what we should be teaching.
Right. So I'm generally bad at language. I've learned French-ish. And I'm very slow with it in relation to, but I learned a lot from learning languages, and I learned a lot from coding, even though when I code, I get easily frustrated, and I don't have the temperament for it. But that doesn't mean I didn't learn anything from it. I can see when I apply my thought processes to it, I can see how I can create something, and I can see the errors in my approach to things. But
the reason why I bring up code, though, is it's accessible.
Yes.
Everybody has a web browser, and everybody can just jump in and start doing it. And you can right from the get-go, you can start building something visual or building something practical. You can do whatever you want. You could just make functions that call each other just to see if it crashes, right? Like you can do it for the sake of logic itself.
Well, and it's complex enough that the discovery can be fun. You just go onto W3 Schools and you just start creating. What do you want to build? And you watch tutorials, and it takes study and it takes perseverance. But when you figure something out, when you actually get it running, it's pretty rewarding. And the exploration in itself can be pretty rewarding.
That's the education right there.
Yeah.
It's the exploration that it's not succeeding or failing. It's making your brain bend over and over again to try and figure out what is not reacting as expected. I think that's the value in it.
Yeah. So I'm usually pretty good at, figuring out a problem, stepping back, getting the idea, getting the, looking at it from different angles, but it's what I do, what happened here, why did it happen, blah, 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 blah. But when it comes to coding and it says it's working, and then I run this, and then I run the program, and it's like, why isn't it working? Error. And I look, and the commas are all in the right place. And I'm just like, all right, I'm going to destroy my computer now, and I will enjoy that. So I'm wondering if we could go into if it's not so much coding in itself, but you're suggesting coding as a way of exploring this. Is it because you are dealing in almost pure abstractions? You're using these things which refer to other things, and you are building something in your head before you're building it on the screen. And you say, okay, I want it to do this, and you have to kind of think.
I think it's more like the perfection of it. Because it's binary, the computer will tell you every time it doesn't work. It will always fail if it's not consistent.
Yeah, because you get garbage in, garbage out.
If you wanted to draw something and have the shading or the lighting look proper, you could draw it with improper lighting and it'll just look off and you won't know why. Your brain knows why, but it won't tell you necessarily why. Like, I suck at drawing because I'll put shade here and then shade here and I won't understand why it looks stupid.
Mm-hmm. Well, the thing in your brain is, that's your intuition talking. Generally, when I get that, like, but it's that I listen to my feedback. Yeah, that's like I listen to my So I listen to my intuition there, and what happens is that's not like, oh, I need to go this way. It's, why am I feeling that I need to go that way? And you can ask yourself that. But it sounds like this would work for a lot of, like, I don't know if everyone would get the same benefit from coding that like you and I did. I didn't get as much as you did. Well, that's
what I aim to convince you of today, is to show you that even if you're not good at coding or you don't program anything exceptional, and if you don't do it for a living and it never makes you money and you never use it for your business, doing that is infinitely more rewarding to your brain than doing math, because math is purely abstract, but they teach it to you just by rules. Chances are the way the teacher learns it best is the way they're going to teach it to you to learn it to you best. Right? Whereas with code, it's an instant response no matter what you try to produce with it. If you give people the basic structure of language and tell them they can write anything they want, they just have to use a concept that was taught.
Right.
Teaching them that process is more value. That's what we're trying to teach them by teaching math to kids.
Right. So it's very similar to writing stories and stuff like that. But
yeah,
one of the hardest things, but one of the hardest things for people is when you say, all right, write me a story. And they're like, what do you want me to write? Well, write anything. And then it's just deer in headlights, because you have that infinity of possibility. You have that pure freedom on the page.
Oh, you just tap them on the bum and say, write me a program that adds two numbers together.
Yes. Okay. But what I'm saying is, when you're writing a story, is that you have these people who have, all of a sudden they're encountered with this freedom that they've never had before. You can do anything with that pencil and that paper. And it stops a lot of people. And now, you can do it like that, and you say, okay, now do this small thing, and now do this other small thing. You
write about your dream last night. Write about your way to school.
So
write
describe
about
a house.
Trying to write.
So make the sprite appear on the screen. All right, now make it move to the left. All right, now make it move to the right when you click another thing. All right, now make it only move when you put an input towards it. Now map the inputs, and now you can have this little guy move around the screen with a couple clicks of a button. He goes when you press it. So you can build upon that, and slowly becomes greater and greater and greater. And hopefully they remember it. And then from there, that's when you have, from my perspective, that's when the practice starts in. I showed you what you need to learn. Just because you've done it doesn't mean you know it at all. It just means you've done it once. And that's all it means. So that's when you need to sit down and put the hard work in, not before you learn anything. Oh, I need to memorize all the concepts. Okay. But you need to engage with it before the concepts make any sense. Context is key. So you need, okay, I did this, and now I need to do it 75 times. So now I don't just know how to do it. I know its use. It's inside me now. And you have this practical knowledge, but it's not knowledge anymore. It's a skill. And you can build skills upon skills. And then with those skills, you can become, at some point, you can become creative and not just like, oh, I'm going to imagine whatever and imaginative, but you can get close to being original, which is, the holy grail of creativity. You can do something original. It's almost like a philosopher's stone. But
I would say it is exactly the philosopher's stone. That's exactly what I'm getting at right there. Mastering abstractions is the philosopher's stone to anything else you could do in the world. It's not just math or graphics or geometry. You're talking about, like, what do I do when my car breaks down? What's the first thing I should check? What's the second thing I should check? My kid doesn't come home. What things should I worry about, and what things are just my anxiety?
You should worry that he's going to come home, because then he's going to get his ass beat.
No, car's broken. I mean, our brains will automatically do irrational things. So just to have our own peace of mind, we have to be able to think and destructure problems rationally. So if you want to live a life with less anxiety, one good way of doing that is to have a better awareness of how the world works. And that's not just meaning how my computer works with software. It means by understanding how to encapsulate and repurpose abstractions, how you could use that everywhere else in your daily life.
Well, you being part of the everything you're living in, you do have to master that part first, and then, gain control, see what you're doing, be honest with yourself about what's happening at your current state of life. Oh, I deserve this, or that, or I don't need to work today and I don't get to work. And, you convince yourself stuff. No, push yourself.
Citizen entitlements without being activists.
Yes. Yeah, we're talking about you. No, but these mastery takes effort, and I think that's where a lot of it comes to. And wondering if I can steer us in a bit of a different direction for a bit, and we can come back.
You could, but I just want to point out, just for the record, that mastery isn't what I'm getting at. I'm not suggesting anyone should master code, because it's a nightmarish life.
But I'm saying mastery of, not mastery of code, or mastering something externally to yourself is a feat that is laudable. And if you think you've done it, if you need to tell other people that you've done it, then you haven't mastered anything. It's like, Margaret
or if
Thatcher
you need credit for it, like accreditation, like a certificate or something, then you haven't mastered it.
Yeah. So mastery of yourself can lead to aptitude in other places. And mastery includes becoming that abstract thing. I keep hearing the word Jedi being thrown around for stuff like this, where you can just go from sphere to sphere and put on different hats and be able to discuss without getting angry, and be able to learn things because you can, instead of just being like, no, I can't, or no, I'm stuck in this silo. So one thing I've encountered, and if I'm going to steer us in a bit, is so we've talked about a lot of what we've been talking about is very positive, very, this is what we can do. Now, one thing I've seen, and it goes against this very heavily, and it's a tendency in a lot of people, and I think I was guilty of it in some of my earlier classes, is that when you encounter complexity, you submit to it. And this is something that I've seen. So and we might have talked about this in previous episodes, but one thing I've noticed a lot of students doing is that you'll get that notion that, oh, there's certain things that we cannot know, and therefore there's no point in trying. And this surrender to complexity, this idea is almost used as a point of data. So people can't talk to each other because we can't go into the mind of another. You can't see life from someone else's perspective. And if they talk
don't even try.
Yeah, don't even try. Yeah. Or if we can't even communicate with people who speak another language or are from another culture. It's like, what about translators? And I remember being in class and people being like, no, you don't understand. And I remember saying, we were talking about how different cultures have different conceptions of the world. And it's like, yeah, duh, but everyone knows what a boat is. How do we have translators? We lost a boat on the water somewhere around here. Are there bodies of water somewhere? So the concepts are, boat or some form of boat or something that floats. So you start with the commonalities, and then body of water, lost, so bad.
Question mark?
Question mark. And then, and they're like, yeah, we saw something weird over in the bay over there. And they have different words and concepts and abstractions for it, but you still have these commonalities. So through all of this complexity, you've managed to forge a way through. And by not stopping, by saying, oh no, complexity, and then, stopping and being like, oh, that's something we shouldn't, we can't know it. So, we're just going to hurt people. And we're just excuse. It's just an excuse.
It's just an excuse.
You stopped trying when things got complex, when you came across a thing. So the adversity is you're dealing with something, and dealing with abstractions is not easy. It's anything worth doing isn't going to be easy. It's actually takes active effort most of the time to do it. Then you need to put those, you put abstract concepts together, you play with them around. But when you give up, it gives you an excuse to not try. And a lot of times,
I think people get like that because they're taught to. They're taught over and over and over again to know the answers. They get tested on the answers. They succeed based on their quality of their answers and some higher authority judging their answers and awarding them some type of credit for it. That to me is the problem of not thinking abstractly. You're not empowering people by having them submit to there being a right and wrong of anything. You're not creating a better population with a better quality of life, or you're not harnessing invention and ingenuity or grit and determination. You're not promoting character in people as human beings or societies or cultures by telling them prescribed truths. If something is universally true, we should all arrive to it no matter how we look at it. We should be allowed to criticize and openly think about every perspective, even if it's not accurate. We should be allowed to openly discuss that thought, that idea, that purview.
Well, even something that other people know, you can push your own bounds and reach that truth through the complexity. But I think you hit on something right on the head there, and knowing the answers it's a great way of putting it. You exist in a world where you know the answers, and therefore you know nothing. Now, if you can become that conceptual Jedi when you can exist comfortably without any of the answers and still blaze a way forward, still work within the world, because it's like, well, do you know anything? Well, I know a couple things, but while I'm working with things I don't know more than with things I know, because the things I know are just tools that I can use to get at things I don't know yet. And working with these conceptual abstractions. So what I was trying to do with, especially my thesis, was I was trying to find something that, I wasn't just trying to ask a question or start a conversation. I was trying to say something that I hope no one had said before. Or if they had, I was trying to say it to people that hadn't done it before. I was trying to do it in a way, especially I did this with my first chapter, was I was putting together a way of looking at something in an abstract way that no one had done, I hope, or at least no one had done quite the same before. So I was trying to create a new abstraction. I was trying to find my own question that I could answer. So there wasn't a question that I could put a right answer to. And what I was doing was working within that space without the answers, as you put it. And I ended up creating something that I was very happy with. And it was very uncomfortable while I was there, but you get used to it, I think, is the thing. You can live in that world without answers, but you're not going to be pushing yourself anywhere new. If you know,
But I think that leaves potential on the table. You know what I mean? Like,
how so?
I mean,
right,
not pushing yourself into
yes.
a comfortable space. What it's doing is it's essentially giving yourself leeway and credit to do as little as possible.
Yes. I
think that doesn't make us better as people. Like, even in the near term or in the long term, like the grand scheme of reality and human species, like, it doesn't make us a better people.
Right.
In general.
Well, no, that's because, well, first of all, you're creating clones. You're only gaining the knowledge that the professor has, and then you're giving the knowledge to the people. So you're just creating a clone. But the other thing is that the world exists as a place that you can't predict, and you will have, there's abstractions out there that are going to hit you that you don't have a basis for. And when they hit you, you need to be able to react as that, conceptual Jedi, and say, all right, this is a new problem, I got to work it out. And when a actual problem that have an answer comes at you, something that is within that realm of answers and that known realm, then it should just be like, well, my example, I guess, would be when I was a victim of arson, and this was a known no. It was a, like, I could imagine what happens when my car burns down or my bike gets stolen. I don't need to panic. I don't need to get too worried about it because I know what to do. It's like I know the answer already. And it's okay. It's just a long, annoying process. I don't like it, but I don't need to, gasp in shock. What am I going to do? What am I going to do? You revel in the chaos because people give stuff and they give you sympathy and they give you.
And along that same vein, having insurance, you don't need to memorize your insurance policy to know that your car was covered, because that's a layer of abstraction that you could pull away from the equation to still benefit your life. You know what I mean?
Yeah.
You could pull that out and still have use for it.
So this is kind of where I wanted to take the tangent. I didn't really know it was going to come here, but you said a few things that I really thought were quite valuable.
Oh, that's what we're here.
So let's bring it back to coding, because I'm not completely convinced, because I think other people might get it out, but I think that you've convinced me on one point, even though I don't think you actually made it, was that we should all attempt or engage with programming in some way, shape, or form. Now, coding in schools. So you get people coding not to like, like a middle school or high school thing, or even in elementary, you can teach HTML to elementary kids, and you're like, look,
I learned it in elementary school.
Yeah. You made this screen blue. Oh, and look, you press a button and now it's green. Oh, wow, it's crazy. And it's actually, it's fun. But at the same time, you can't just be like, because you got parents and people saying, "Oh, what are you teaching them? Useful skills. They don't need to learn tangents and cosine, and you better be teaching them. They're never going to need this." It's like, well, thanks for limiting your own children. But at the same time, to that
note, we already do that. We already say you have to either take art, music, or language. Some other schools have drama class. Mine didn't. Some other schools have programming class.
Yeah, they're not.
It's already a type
teaching
of
French anymore.
It's an elective compulsory, though.
They took history out. History's been on the chopping block for a while. Geography's been on the chopping block. Even gym now is on the chopping block.
That's brutal. Everybody has a body. We should all know how to take care of it.
Your mind, that's important. You got to expand. So
that's another topic for another day.
Yeah,
I would love to drill into that.
Yeah. So one of the things that I'm thinking is that, if you teach it in schools, but you don't teach it solely, you're not going to be able to get away with it. You don't teach it solely with the aim to, you're going to learn how to do this because coding is the future, blah, 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 learn to code. No, you need to learn to code because it's something you can learn. It's an outlet for creativity and effort and positive effort. That's creative effort. This is productive. It's a productive
To me, the
pursuit.
more important part is the abstractions. The way it teaches you to handle and manipulate abstractions is the value.
Right.
It's not the output or the outcome.
No, but that's what I'm saying is that it's valuable because, and the abstract nature of it adds value to its productivity. So it's not like I could make a bunch of blocks and I could do it, but then I'd have a bunch of blocks, but there's nothing much else to that. I could code. I could go on my computer and render and code a bunch of blocks on and make a program where I could click on them and move them around. Now, the thing is that productivity has made that program, but it's also given me a skill I didn't know before. I can cut a bunch of wood up. But here I'm working with more than just the things that allow me. I need to work with, mathematical abstractions, just like you're saying. And that productivity isn't the endpoint, just like you say, the endpoint, the end,
the goal.
Yes. sorry.
I didn't think it could be that simple. Sorry.
I had a rough night. Sorry. If
no,
everyone's listening, this is why I'm a bit,
usually I'm more helpful, but I was thinking of 6-syllable words.
Yeah. So the goal, the ends to it's, again, I think what I'm saying is that it's the journey that's important here. And the journey is that practice with using those concepts to create the thing. The end thing, it doesn't matter. You got blocks on your screen now and you can click on them. But the things that you have to do to get to that are those abstractions, and the practice with playing with those will make you look at things differently. And I think that's what you're trying to get at.
Well, what I'm trying to get at though is similar. But it's
because nitpicking words, I could just rephrase it a bunch because the word doesn't really matter. It's the concept behind the word,
but
the abstraction
the part
that
we
matters.
Keep skipping over though is the syntax. There's structure to it. It's very, very ordered and structured, and it's compiled and it's interpreted, and it's that's why it always produces the same output every time you give it the same input. Every time you write a code with an exception fault in it and it crashes, it will always crash. It's never going to work sometimes.
Well, it's perfectly logical.
Right. So it's just like math, or just like learning scales in music, and it's just like learning shading or lighting in art, and it's just like learning acting or memorizing lines or Shakespeare in drama. It's exactly like all other compulsory electives in the sense that it has schoolable structure to it that is also useful in a career. But the aftershock to it is exactly the same as music and art and drama and law and language, in the sense that it opens your mind to an entirely new scape of opportunity. And it's not just opportunity in the sense that you can code an engine that's like super complicated that nobody else did before. It's as simple as being able to script a little code that helps you in your construction business to price estimates. Right? Like it can be that simple, where you just need number of square feet, price per yard of material. That's how much my flooring's going to cost. It can be as simple as that. But it's actually more practical and useful than playing an instrument, because most people don't make money playing instruments. But we recognize already the intrinsic value of music in school. We already recognize the intrinsic value of art. You know what I mean? It's like, it is art and it is music, but it's also more. So it should be the obvious compulsory that people learn in addition to electives, in my opinion.
Okay. Yeah. Okay. I was looking at it more abstractly. So
there's so much to it. Like you can use it to apply to your other studies even. Like if you're studying geography and you want to try and get a map of like coastline, well, anybody who's watched a shore ebb and flow knows that the coastline changes every time the waves move.
Yeah, as a
Write program
historian.
that could calculate with a lot more accuracy than you could a Fourier transform of a shoreline, and you could get a really, really accurate, detailed estimate of the average shoreline for a country, and throw that at your geography teacher as just a you know what I mean, for extra bonus points. Like,
Yeah.
It's a fun way of playing with education, to be able to do anything you want with one domain of expertise like math and applying it to another domain of expertise like geography, and then throwing it into an epoch time scale and step it back to your history teacher for a geography of a mathematical equation of a computer science application. Like, it's the one thing that's cross domain that we don't teach people.
Yeah. So, aside from the obvious other benefits, like now you know how a computer generally kind of works, because a lot of people,
the obvious stuff like that, because we use software and everything. Because
there's a lot of people, it's like kids nowadays are so much computer illiterate, and it's like, actually, I don't believe that's true. It's our generation that had to mess around with DOS a bit
and dial up. We had to dial into the internet, not just grab it out of thin air. Like, it's
or those like computer hobbyists from the 70s and 80s who had to, the computer was a kit. And then
like Shenzhen IO.
Yeah. And you had to like go to Radio Shack and I need this kind of resistor, and then you'd have to go home and solder it, and you get the drilled motherboard, but then you have to solder in all the pieces yourself, and then program the thing yourself, and then boot it up, and then hopefully it works. And then
it's like, what's thermal paste, and what's a PCB, and what's a capacitor, and what's a resistor, and what are ohms,
there's no
what's
internet.
Voltage, and what's amperage, like all of these other concepts.
There's no brown guy in the middle of India who's like, okay, here's how it works. By the way, if you are one of those guys, bless you. Those guys from India who like, all right, now we're going to be looking at how redundancies and SQL work. And I'm just like, thank you.
But not to stick it strictly to coding though, the idea of abstractions and conceptualized learning over learning specific traits or properties or details, I think is the emphasis and focus of what I wanted to get at.
Right.
Because it doesn't apply, even though code is a perfect, like programming is a perfect segue into all these other manifestations of it, and knowledge and education as a whole, is the way I understand wisdom, or like fulfillment, the things that actually matter to us, like core values and love and like richness, and not but like your bank account richness, but like your richness of family and friendships, and like the depth of life itself, the essence of quality.
How well are you living, not how are you feeling?
What's that? Yeah, how are you feeling about this smoke?
one of the things that I gathered about, at least from my life, is that recently I've been noticing that I need to teach a class. All right, I don't know anything about that. I'm going to go down and learn it. And that's the thing I can do now, is that before, when it's like, I need to write a 500-word essay, which I can do by accident now, like the writing, it just takes time. You just got to write, and then eventually you'll just get better at it. But, and it takes practice. But the thing is that before I didn't know how to learn. So going to university forced me into a situation where I needed to learn. Now I can do all the stuff that the professor was, holding my hand with and doing that and I can just go and find information and put together narratives and histories and ideas all on my own now. So I didn't learn the narrative of history, which is what a lot of, I guess, these postmodern students are thinking, is that they're just teaching you, they're teaching you this narrative, and that narrative is the one you're learning. But the thing is that they're not understanding that they can make their own one up. They can do their own reading and come to their own conclusions. You don't have to be subject to other people's conclusions. Now, the retort to that would be, but you're using a gendered blah, blah, blah. Okay, screw off. I'm done. But what I did was I learned to make my own. I learned to learn, essentially. I was able to work with my own abstractions and create them too, not just work with like the abstractions that are readily available around me, but I learned to make my own that I can play with.
And that is ultimately the goal of education, right? I mean, some of it is to make us functional human beings in society, but we want people to be autonomous beings in society.
Yeah, there are things you do need to memorize, unfortunately. So like, especially when you're working with hazardous materials, you need to know the temperature at which this explodes, or so these things. And sometimes you do need to sit down and memorize things, but that's one way of gaining it. That's actually, you know what? Nuts to this. I'm just going to lay it out. The way I see it is that there's three forms of this. You have data, information. We laid this out in our first episode, episode 1. Or maybe episode 2, it might have been the data episode. You have information, data, like information points. You can use that to create knowledge, things you know, so you have, the first is just dates and names, values. And then the second one is you have a sets of values that create knowledge. So you have, what does this mean? Then you can use knowledge to create wisdom. How do I apply that? And wisdom is, for me, what you want to be working towards, because you get data by memorization. You get knowledge by putting data together and coming to a conclusion. You get wisdom by using those conclusions. And you do need to gain the data. How do these material works? What happened? What are the dates and names? Why did they do that? Knowledge. Should I try and avoid doing something like that? Wisdom. So I know this is simplistic, but this is generally how I've seen this. You get these 3 tiers of information, and I'm not the one who came up with this at all. In fact, I want to credit maybe Carl Sagan, but I don't know where I got it. Don't know the epistemology of this thought process. So I'm using an abstraction that someone else came up with, but I've modified it to my own use. It's not my algorithm, but like I said, originality is the holy grail. So, but I'm using it for my own means, and I've adapted it and I've abstracted it on my own. Now it's grokked in there. So
I think that might be a good place to take a break. Maybe when we come back, we can open us up by delving into the whole grok.
Okay, yeah, I don't know how much I've got left in me, because like I said, I had a really weird night.
Yeah,
so.
we can terminate this and we can add the next one to the AI episode, I guess. That would work.
Oh yeah, you wanted to do an AI episode. So yeah, because I am running out of steam here.
Yeah.
So as host, I guess.
Well, give us your Jerry Springer final thoughts.
Yes, give us your final thoughts on why you are the father of this abstraction. I don't know how to do a Jerry Springer
used to do that all the time.
I know. I used to turn the channel off when The Simpsons would end and Jerry Springer would start.
Oh, garbage.
I was like 10.
Anyway, your final thoughts, because I think I'm probably going to get into a lot of it in detail when we go into the AI component.
Yeah. So my final thoughts, I embrace complexity, become a conceptual Jedi, live within the abstract, make your own, and don't settle.
But that's not to say that skills aren't valuable, techniques aren't valuable. It's just
but
the exclusionary perspective of of the way we're teaching these days is
Yeah.
what I'm vehemently opposed to.
Yeah, I feel
What's
like
right is so wrong.
This distinction between physical labor and mental labor is in itself kind of weird. Now there are things that are, you can turn your brain off and do, but usually when I turn my brain off, it's because I'm listening to an audiobook while I'm doing physical labor. I built a shelf here while I was listening to a book. So, I turned it off when I was using the saw, so not completely safety unconscious. So, but yeah, that's, I think, a talk for another day. So, I guess final thought would be go out, try your hand at a basic script or two and see what it is. Start simple, turn off a program and on with a click, bind something to your start menu key, who knows, something, and then just experiment, see where it takes you.
And play with open source software. You got nothing to lose. Just install Blender and see if you can make a 3D cube bounce, because it's really easy. You should just do it because you can. Because computers, I never thought in 1,000 years when I was young that I'd ever have the opportunity to make things that look better than video games. And now you can make photorealistic stuff from an $800 computer in your bedroom in your spare time. Like, it's just phenomenal what we're able to do. But yeah. With that, thank you for indulging. It's been real.
Yeah. Check back to see updates.
Like, share, subscribe.
Yeah, share it with your friends. It would be great to have more people commenting and having their views on here. So, and like always, go with much gravitas frivolously into that abstract night. Ciao.